Unit 18, Part 1. Welcome to our final unit on proofs and invalidity for relational predicate logic. So here we will learn to prove valid arguments valid, and we will also learn how to do theorems, and we will learn how to prove certain arguments invalid in relational predicate logic. But a logistical remark to begin. With the proving arguments invalid, just like in Unit 16, you were not required to learn the natural interpretation method for proving an argument invalid. Same here. She has a couple of pages, 350, 351, where she goes over the natural interpretation method of proving an argument invalid. You can skip that. You will be asked, but you will only be asked to use the model universe method to prove an argument invalid. So again, we'll need to learn how to translate quantify statements into their meaning in specific domains. In the model universe sense of domain, right? Where just all you do is specify the number of individuals, either A for one individual or A and B, for example, for a domain of two individuals, A, B, C, three individuals, and so on. But you'll only be asked to use the model universe method, not the natural interpretation method, which means you can skip 350 from in the natural interpretation method, ... Okay, you can skip all 350, and you can also skip the first paragraph of 351 and pick back up, start studying again. The model universe method is also applied on 351. Start from that second paragraph of 351. Okay? All right. So, if you recall, we motivated the introduction of relational predicate logic in Unit 17 by examining an argument which we all clearly grasped as valid, but the validity of which we could not grasp or express using the resources of monadic predicate logic. It was the argument, premise one, some people don't like any dogs, all dogs are puppies. Conclusion, some people don't like any puppies. Well, now we finally have the resources, or will learn the application of the rules. There are no new rules, right? There are no new rules. There is a slight wrinkle in the application of the rules. It's going to come down to just the A for X part. There's a wrinkle, there's an added complication in the application of the rules, but there's no new rules. So the rules governing quantifiers are the same as before. Universal and existential instantiation, universal and existential generalization. Their application is more complex because in each case it's only one variable to one quantifier being added or removed when you're instantiating or generalizing, and the formulas you're instantiating or generalizing have more than one variable, right? Because they've got relational predicates like L, X, Y. So it's more complicated, but with these resources we can finally prove that all the dog haters are puppy haters. Okay, so she begins her chapter, Klenk begins her chapter with the proof for this argument, and if you remember the beginning of the first couple of parts for the lectures of Unit 17, I did begin on the argument here, on the actual formal proof that is presented here on page 342. But now we'll go through it properly. I didn't complete it there. I just wanted to give you a sense of where the translation of those sentences, of those arguments, were headed. And now we've gone through all of 17. We've seen how to translate categoricals with variables like you have in premise 1 and the conclusion here. Quantifiers like you have in premise 1 and the conclusion here. Within either subject or, in these cases, predicate phrases of quantifier of categorical statements. Okay, so the translations, that was I put the skeletons of this argument on the board in the beginning of the Unit 17 lectures, so you can see the form of the statements, right, as per the translations from those English sentences of the argument. Some people don't like any dogs. Some people don't like any puppies. That's the first premise and the conclusion. How they translate into the symbols. I won't talk any more about that now, but now we're looking at how to get from the two formulas that are the premise, the two formulas that are the two premises, to this conclusion, okay? And we'll see the rules in action, and there's quite a lot to learn in just the application of this first proof about how proofs go in relational predicate logic. All right? So I've started, and I've left, the next step is really a crucial one, so I'm going to do it in front of you. Got the two premises, so notice this. So remember, back to Unit 15, when we learned the rules for instantiation and generalization, it was hard rules before easy rules, and part of the motivation for that was blocking the combination of you couldn't do it. So what are the two hard rules? Existential instantiation and universal generalization, remember? And both of those were the flag rules, right? So one of the things we wanted to do was block using the information of an existential statement, right? So doing an existential instantiation and then taking that sentential singular sentence, right? Taking that instance and then universally generalizing it over it. And the flag rules stopped, as we wanted them to do, stopped us doing that. So you couldn't if you existentially instantiate from something, you write say flag A, right? But how do you do a universal generalization? You're only entitled to do a universal generalization you're only allowed to do a universal instantiation on a formula that has been derived within a UG subproof, within a quarantined UG subproof, right? So you had to set up the subproof, right? Flag A or flag B, call it an A flag subproof, derive that instance, and then you were entitled to do universal generalization from that instance, right? And so if you've done an EI and written flag A, and then you try and do flag A to get the instance for UG, you can't do it because A has already appeared in the existential instantiation, right? And the flag letter you're trying to do is not new to the proof. You've broken the flag rule. Or if you try the other way and you try to set up the UG subproof and write flag A, now you try and do the existential instantiation, and what do you write? You write EI flag A. If you instantiate to A, A is not new to the proof because writing flag A, flagging step for universal generalization, setting up the UG flag, that counts as that letter appearing in the proof. So in trying to do the existential instantiation, you've broken the rule, the first rule of flag letters. The flag letter has to be new to the proof. Okay, so that meant in practice, UGs, universal generalization, the instances from which you do a UG were in practice derived from only universal statements, right? That's why hard before easy, second of the two applications of that advice was set up for universal generalization before you do what? Universal instantiation, because in practice it was just you'd have a set of universal statements, as say the premises, and then you do the UI, universal instantiation is an unrestricted rule. You could do UIs, you could instantiate to the same letter that you flagged, and then you could get the instance and do the UG. Okay, I say all that because that blockage isn't quite going to hold here. In fact, in this proof, we're going to see, because we've got relational predicates, right? We've got two place predicates. Here, we're going to be working with L, X, Y, right? And so there's two places. We're going to have proofs like this one, where we're going to do an existential instantiation and flag a letter, but we're also going to do a UG from the bottom, right? And that UG will, we still have to follow those rules, right? The UG will be on a different letter, B as opposed to A, right? Be on a different instance, but that combination is going to be possible, right? As opposed to the monadic predicate logic proofs of Unit 15, where there was really no possibility of combining EI information or from getting existential instantiation information to the instance from which we do a UG. Here it will be possible. You EI to one letter and you sort of UG from another one. We'll see how it goes in practice, but I just want to point that out as something to notice as we go through this proof. Right? There's going to be an EI, you're going to flag a letter, but we're also going to need to do a UG, and that combination is going to be possible. Okay? I'll start the proof in part 2.